Hi, I'm Amy Herfel,
I'm John Ford.
I'm Joe Spittler.
And I'm Zachary Torres.
and this is Group 12's project on carbon emissions around the world and its extension from our first project. To begin today, we're going to discuss the problem with CO2 in our atmosphere. Carbon dioxide causes the greenhouse effect, and that's when the molecules of carbon dioxide in the atmosphere collect the infrared waves from the sun and reflect them back down to our Earth. This causes a warming effect, which can cause severe weather events, sea levels to rise, and change rainfall patterns. The reason this is an issue right now is because in the past 3 million years, there has never been more carbon dioxide in the atmosphere than there is right now. This leads us into our question: how does a country's participation in the Paris Accords affect the mean emission rates from 1990 to 2018?
So some background on the Paris Accords. It was signed April 22nd in 2016, and 193 countries signed, but 8 countries did not, including Iran, which we'll talk about in a little bit. But the main goals of the Paris Accords were to drastically reduce the greenhouse gas emissions, to slow the global temperature from rising more than 2 degrees Celsius. And this was to review each country that signed their efforts every 5 years was also a main goal, and to provide funding for developing countries to mitigate the climate change from those countries. And like I said, every 5 years, each country submits what's something called a National Climate Action Plan, which basically just covers what they're doing now and what they're going to be doing in the future. So our plan is to use a 2-sample t-test to determine if the mean emission rates for the 2 countries are the same. We chose 1 country that was in the Paris Accords and 1 country that was not. We created a probability plot and distribution plot, and we use a significance level of 0.05. We assume that the data set values are independent, our random samples are normally distributed, and the variances are equal.
So moving on to data collection methods, as Joe mentioned, we decided to have 1 country that was in the Paris Accords, which just so happened to be France, and 1 country that was not in the Paris Accords, which was Iran. And also the data that we collected is the carbon emissions of countries around the world. And as you can see, based on the flow chart here on the screen, you go to the data set in Kaggle, and then you search up CAIT in the Kaggle search bar, go into data sets, and then the first thing that should pop up, the first result should be carbon dioxide emissions from the world, 1990 to 2018. Moving on to the probability plot. So first, we wanted to make sure that the mean emissions of both countries were normally distributed. So we use the probability plot function in Minitab, and as you can see, the p-values given are both greater than the p-value and or the significance value that we use, which is 0.05. And we also did a test to see if the variances are equal, and so what we did was we took the square of the standard deviation of Iran, and we divided that by the standard deviation squared of France, and we got 2.63, and 2.63 is less than the parameter of 4, which would signify that the variances are not equal. So since it's less than, we can assume that they are equal. And so, yeah.
Alright, so here's our data analysis from Minitab. We have our null hypothesis, which is that the mean carbon emissions from both countries would be equal to 0. And then our alternative is that the mean carbon emissions from Iran would be greater than the carbon emissions from France. And then you can see we have the t-value of 38.44. And then our graph over here, you see the rejection region is anything greater than 1.699, and since 38.44 is obviously greater than that 1.699, we can reject the null hypothesis.
Okay, on to an overview of our results. To restate the null hypothesis and alternate hypothesis, we said for the null that Iran and France will have equal mean carbon dioxide emissions. And this null hypothesis was rejected because, as previously stated, our T value was greater than the T alpha value. Overall, this means that we can conclude that the alternate hypothesis is true.
And then our decision, so the country's participation in the Paris Accords correlates to a smaller average CO2 emissions. And so we used France and Iran as our countries, and then we applied those to kind of just as a reference for the entire world, pretty much, as it pertains to the Paris Accords. And then we decided our study was valid because all the assumptions stated previously in the slides are met, and we have stated our conclusions in these slides. And then we also thought up some future possible studies that we could do, which include we can analyze more and or different countries to kind of see if these same things apply with the Paris Accords. And then we also thought that you could bring into account the financial aid that the Paris Accords gives to smaller, more developing countries to see if that helps them with lessening their CO2 emissions. And then we got our sources here.
Thank you for listening.